Okay, so we have this problem and it wants us to find and give our solution in interval notation. All right, so our function is f of n is equal to n squared plus 4n minus 21 over n squared plus 5n minus 36. All right, I'm going to try and factor my numerator and denominator and see if anything cancels before I look for my domain. So my denominator, I have negative 36, and I want to see what the factors are of 36 that add together to get positive 5, if there are any. So negative 36 can factor into, let's see, negative 36 and 1, negative 18 and 2, negative 12 and 3, negative 9 and 4, negative 6 and positive 6, and then all the negatives kind of backwards for this. Ooh, give me just a second. All the negatives could be backwards. I could have negative 4 and 9, negative 3 and 12, negative 2 and 18, and negative 1 and 36. All right. But only one of these adds to positive 9. It's this one right here. If I add these two together, I get positive 9, positive 5. So that is what this denominator factors as. So my denominator factors as x minus 4, x plus 9. All right, now let me look at the numerator. I have negative 21, and I want to look at all the factors and see if I can find one that adds to positive 4. So negative 21 could be negative 21 and 1, negative 7 and 3, negative 3 and 7, and negative 1 and 21. Alrighty. Only one of these adds to positive 4. It's this one right here. If I add these, I'm going to get positive 4. So that's what my numerator factors as. It factors as x minus 3, x plus 7. All right. So now that I've done all this, I can see that nothing cancels. I don't have anything that I can cancel in my new fraction. All right. But now that I've got it in this form, I know that my denominator cannot be equal to 0. That's the only condition that I have with fractions, is that my denominator cannot be equal to 0. So my x minus 4, x plus 9 cannot be equal to 0. Alrighty, that means that x minus 4 cannot be equal to 0, and x plus 9 cannot be equal to 0. Alrighty, I'm going to add 4 to this side, add 4 to this side. I'm going to subtract 9 and subtract 9. All right, so then I'm going to get x cannot be equal to 4, and x cannot be equal to negative 9. All right, all the other x's I'm great, good, and wonderful with. My denominator won't be 0 in those cases, so I'm good. So what that means is my domain goes from negative infinity to negative 9, jumps over negative 9, goes from negative 9 to 4, jumps over 4, and goes from 4 to infinity. And this is my domain. I can't have negative 9 and I can't have 4. So this union tells me on the number line, I'm going to include all this stuff until I get to negative 9. I'm going to jump over negative 9, and I'm going to get all this stuff, and I'm going to jump over 4 and get all the rest. So this would be my solution.